It's not done for all pavements and all projects, not at all by any stretch of the imagination, but it exists in these DOTs. A little over half don't consider user costs, so they just consider cost to the agency. Discount rates that are used are typically still around 4%, but some use OMB values, which currently are lower than that. I'll show you that in a sec. And there is a trend to see the life cycle cost analysis moving towards longer analysis periods in the range of 40 to 50 plus years. The rehabilitation timing that you put into these life cycle cost analysis tends to come from pavement management systems, ideally data-driven. And about a little over half of these DOTs that use life cycle cost analysis actually include a salvage value for a particular pavement. General guidance from life cycle cost analysis still comes from this document, which was published 17 years ago. And it recommends procedures for doing life cycle cost analysis and sets some very reasonable standards on how to consider these costs. There are some key issues associated with life cycle cost analysis, and I'll briefly cover discount rate, salvage value, user cost, and deterministic and probabilistic calculation methods. So discount rate selection, if you're doing a life cycle cost analysis, discount rate selection can be quite influential. It basically influences the time value of money, which is kind of a big component of life cycle cost analysis. So OMB guidance would say to use a real discount rate of treasury notes and bonds that mature at about the same time period over which you're doing the analysis. So for us, we're at the 40 to 50 year range typically, so we're looking all the way at the 30-year. And the real discount rate right now, latest revised in December 2014, was 1.4%, and that actually assumes assumes a 2% inflation for the budget. So you can see that 4% that a lot of agencies use is a little on the high end now, but it depends upon how you want to look at it. Salvage value versus remaining service life. It's really this idea of salvage value is assigning a value to a pavement at the end of the analysis period to capture the value that still remains in that pavement beyond the analysis period. So there's a couple ways to do this. The first issue is just a salvage value versus a remaining service life. So you could assign a value to remaining service life, the idea that the pavement at the end of the analysis period can still be used and driven on and it has a remaining service life, and assign a value to that. And the other option that some agencies do is assign a value to just the pavement materials and assume or calculate that they have no remaining service life, so the value is just specifically for the materials that remain in place. So a couple different ways of doing that. And then allocation of salvage value. And this issue is basically, well, who owns the salvaged materials? So if it's the materials, is it the contractor or the owner? Oftentimes in contractual relationships, the contractor ends up owning the materials once they transport them and haul them away from the site, but sometimes it is the owner. And also understanding where the benefit is accounted for. Do you assign that benefit of salvage materials to the old project that has maybe no more service life, or do you assign it to a new project that is going to take its place or going to use those materials to its benefit? So there are a couple different ways of doing things. User cost is another typical issue. Typically you consider vehicle operating costs, delays, and crash costs, and those are usually only accounted for during construction periods, so during initial construction, during follow-on rehabilitation and maintenance activities, but not in between when none of that is going on. The assumption is when you're comparing alternatives, the in-between costs are basically the same. And as we looked at earlier, some organizations do consider user costs and some don't. The costs, when they are considered, vary considerably. These are some numbers from that original life cycle cost analysis document to give you an idea of the range that they saw, and these are actually updated to 2015 dollars. So user costs can be pretty variable depending upon what numbers you actually use, and in fact they can be quite large, especially in urban areas. In fact, sometimes being large enough to be much larger than the agency cost for a particular project. And then finally, life cycle cost analysis. There are basically two fundamental ways that this document talks about doing it, which would be deterministic versus a probabilistic approach. So deterministic approach uses fixed values for all the inputs and basically gives you one number and says, boom, here's the cost. The probabilistic approach uses probabilistic distributions of numbers as inputs, and so it's able to give you an output that gives you a range, a distribution of costs for life cycle costs, and basically says, okay, you can still pick a mean, but there's actually a range associated with that. You can use life cycle cost in project delivery, and it has been used, typically in like a design, bid, build approach or a hard bid approach. The agency typically does the pavement type selection, and the way you'd see life cycle cost come in would be something like an A plus B bidding, which accounts for perhaps initial construction user costs, with the B being the time that you need to do the construction or the time that a contractor needs to take lanes to do the construction. So that is basically accounting for user costs in a design, bid, build. Alternate design or bid projects, the contractor is allowed to choose from design alternatives. They may be different material types or not, and you must calculate the life cycle cost of these alternatives, and that life cycle cost is then used in the decision process. And then finally, there are variations of design build, such as design build maintain, design build operate maintain, where bids to do the project necessarily reflect the initial construction cost, but they also have to account for maintenance and everything else that goes on over the life of operation and maintenance. So you can use life cycle cost analysis in the project delivery mode. Available tools, typically real cost by the Federal Highway Administration. This is an Excel-based tool, is the standard. It's based on the original document that we talked about earlier. And there are a number of other life cycle cost analysis tools. Almost all of them for pavements are based on this same original document, so the same underlying assumptions exist, which is good. It's nice to have a standard that multiple tools can adhere to. Okay, shifting over now to sustainability rating systems. Big picture, they're a list of sustainability best practices with an associated common metric, and usually that metric is points. Reason being is there are a number of different metrics for each individual item, and none of them have the same units, so we convert them all to points. Their purpose really is to encourage sustainability practices and actually communicate sustainability in an effective way, both maybe to the project team or professionals who might be a little more technically oriented, and also to the general public whose money we're spending and who are eventually using the road and the pavement. The appeal of a rating system is its ability to measure sustainability in all of its diverse components, or at least its attempt to measure sustainability in all of its diverse components. It's a simple communication tool. It's nice to talk about a road that earned 42 points, and that gives you a feel for how sustainable it is, and then we can talk about some of the details. And it also provides a context for innovation. You can use it as a set of sustainability best practices and then manage or design your project and pick from those and do some innovation and get credit for some of that innovation. And if you look in the building industry, I think with the LEED rating system, which rates buildings for sustainability, more or less, I think that's one of the big benefits it's had in that industry. There are a number of rating systems that are currently available. I've sort of simplified them into maybe a couple of statuses here and divided them up into road systems, which specifically apply to roads, and infrastructure systems, which apply to basically all of infrastructure type things like, wastewater treatment plants, things like that, but could also apply to roads and have been applied to roads. So there are some that we would, and you can maybe argue the status of these, but more or less there's some you could classify as kind of older and been used on a number of projects, some you could classify as operational and growing, and some you could classify as development or research efforts that haven't really gone much further to date. I've underlined 4 of them: Green Roads, Green Lights, Invest, and Envision, and you can see those in the guide document in a little bit more detail, and I'll show you just a brief overview of each one of those. So Invest by the Federal Highway Administration was first published in 2012, and actually version 1.1 was released earlier this year. And it's described as a voluntary sustainability self-evaluation tool for highways. So it also includes the system planning phase, as well as project development, which is sort of the typical road project, design and construction, as well as operations and maintenance associated with an agency. So you can sort of evaluate any, all, or one of those, or however you choose to use that. You can see the web address where it's available. And if you just look at pavements, about 48% of the points available within the project development section, which amount to 14 criteria or credits, are pavement related in one way or another. If you look at Green Roads was originally developed at the University of Washington. It's now administered by the Green Roads Foundation, which is a private 501c3 nonprofit. It is run as an independent third-party rating system, so very similar to the way LEED is run as an independent third-party rating system. Certainly you can use the material to rate things yourself, but there's also the option to do an independent third-party rating. You can see where to find that. And about 49% of the points, or 26 credits, apply to pavements specifically. Envision, version 2.0, comes from ISI and a collaboration with Harvard University, as you can see, first published a couple of years ago, and it's a self-evaluation or third-party rating tool. It's an infrastructure systems tool, so it applies to all infrastructures, but can apply to roads and pavements. And about a third of the points, or 31%, have something to do with pavements. Green Lights is actually a program that originated with the New York State Department of Transportation a few years ago. It's a self-certification program for transportation design projects, so it specifically concentrates on design. There is also an equivalent program that they put out that covers operations, available from the same website, if you can see the link there. And about 10% of the points, or 16 credits, are directly applicable to pavements as we're talking about them. And then finally, it's probably worth briefly discussing LEED, as this is sort of the preeminent rating system available. But LEED comes from the U.S. Green Building Council. It's probably, depending upon how you count it, sort of 18, 19, maybe even 20 years old now. But it generally applies to buildings. Maybe the most relevant to pavements and roads would be LEED for neighborhood development, or LEED ND. It's a third-party rating system for sustainable development. It's got a minimal treatment of roads and doesn't go much beyond recycled materials and access to different transport modes. And very little of it, 6% by our count, applies at all to pavements. So if you're looking to rate pavements, or you want to show sustainability features of pavements, LEED probably isn't going to get you there. And I don't think that comes as a shock to anybody, because it's a building rating system. So if you look at these rating systems out there, what do they typically talk about when it comes to pavements? So here's a listing of some common pavement-related items that they typically address. So the ones highlighted you'll find in pretty much any system. So you'll see reduced energy. They'll ask for reduced energy consumption in materials production, minimize materials used in a particular design. You'll typically see some sort of waste management or waste minimization, and then end of life you'll see materials recycling and materials reuse are very common. And some of the less common elements for these systems, and I should say the numbers that I'm showing you here, we actually looked at 11 road-related systems and counted up all the different credits and put them into these categories to see kind of where we stood. Some of the less common ones are things like asking for durable structures, so long life pavement design, worker and job site safety, job training, quality control, and life cycle cost analysis or cost benefit analyses. So you can see there's a sort of there are some things that are less commonly addressed, and there are some things that you should typically expect to see. So if you go to use a rating system or investigate one, look for these kinds of things and look for the things that you value. That you would like to be measured. State of the practice of these two areas for life cycle cost analysis, it's generally accepted. Most DOTs use it at some level. The FHWA interim bulletin is still the industry standard, although if you look at what the GAO recommends, they recommend updating a few of the FHWA guidelines that go with it. But and if you look at rating systems, their use is I would categorize as infrequent but growing. Rating systems tend to focus on the entire road and not just the pavement section. The pavement system would be a subsystem of the road. And the treatment of pavements within these rating systems varies greatly. So if you're looking at them to express sustainability of pavements, look at those credits and think very carefully about how they address pavements. And I'll turn it over now.
All right. Thank you, Steve. Steve started to get into the methods for doing assessment of sustainability. He covered life cycle cost analysis and the rating systems. Now we want to turn it over to Alyssa Kendall, who is going to get us into discussions on the pavement life cycle and then life cycle assessment. So Alyssa?
Thanks. So I'm going to talk about the pavement life cycle and pavement life cycle assessment, and I think Steve did really an excellent job of providing context with his discussion of pavement sustainability, life cycle costing, and those rating systems. So to start with, we have to examine the actual pavement life cycle to consider really what steps or what stages in the life cycle we're going to model in a life cycle assessment. And one of the key principles for life cycle assessment is that we start at the origin of the materials and inputs we're using in our system. So we're always going to start at the mine, quarry, or oil well, and we're going to examine each stage of the life cycle all the way through to end of life, which is where we'll retire a portion or all of the pavement system and examine the final disposal of those materials or recycling and reuse of the materials. So when we actually do a life cycle assessment, we take that vision of the life cycle and we track the resource or environmental inputs to the system and waste and pollution outputs from the system. And the idea here is that we're going to track these environmental flows at each life cycle stage, and by doing so, we can assess the system-wide environmental impacts associated with a pavement. One element that's missing from the diagram I showed on the previous slide is pavement design. So pavement design is influential in the fact that it actually affects the material type and quantity that we use, and the frequency of construction, maintenance, and preservation activities, and of course how those affect the use phase and how, for example, design life might affect the timing and recyclability at end of life. So the pavement design stage is critical to include when we consider life cycle assessment for pavements. So taking that, we can conceive of a practical view for pavement life cycle assessment and think about each stage of the life cycle that need to be considered. So if we start at the top of the diagram shown on this slide, materials production, in this case we're looking at all the processes involved in acquiring pavement material and processing or refining those materials. In the pavement design stage, we're going to actually consider essentially the structural and functional requirements of a pavement given specific site conditions, so subgrade, climate, existing pavement structure, traffic loadings, etc. And then we're going to determine the pavement structural composition and accompanying materials. Of course, this process of pavement design will affect what materials and the quantity of materials are being used in the pavement system, and will also affect the construction process. The construction stage includes everything starting at mobilization of equipment, delivery of materials, material processing, on-site such as mixing, and then all other processes associated with on-site or field processes for construction. One thing to point out is construction here and in life cycle assessment of pavements refers not just to initial construction but to rehabilitation, maintenance, and preservation activities. Finally, in the use phase, we tend to examine actually how the pavement interacts with its users and the environment. So that means that we'll consider